Hi everyone, my name is Cheng-Ying, and today I'll be presenting the science of muscle fatigue, how nutrition and training affect performance. Have you ever been in the middle of a workout, maybe lifting weights or playing a game, and suddenly your muscle just stop responding no matter how hard you push? That moment inspired me research. I'm a biochemistry student and athlete, so I often notice how my body reacts to change in sleep, stress, and nutrition. Some days I'll feel unstoppable, while on others my strength fade, faded quickly. It made me wonder what's really happened inside our muscle when we get tired, and can science help us train smarter and recover faster? Okay. According to Christian Morrow's TED Talk, the surprising reason our muscles get tired fatigue is caused by more than just running out of strength. It's a combination of ATP depletion, neu- neurotransmitter change, and metabolic waste buildup. He explained that even when our muscles still have energy, our brain may intentionally reduce muscle activation to prevent damage. It's like an internal safety switch that limits performance before total exhaustion. This idea fascinates me and led me to explore how our brain, muscle, and nutrition all work together to create and prevent fatigue. From this, my main question is how do diet, muscle, metabolism, and brain signal interact to influence athletic performance and fatigue? Understanding this relationship could help athletes recover faster, perform longer, and protect their bodies from overtraining. I argue that three key systems determine how and when fatigue happens. First one, the central nervous system, which control efforts and motivation. And the second one is the muscle energy system, which um, supply ATP. And the third one is nutrition and training habits, which can delay exhaustion and speed recovery. Okay, okay. First, central fatigue. Uh, when we are tired, our brains sends weaker signal to our muscle. Research by Wong and others shows that change in neurotransmitter like dopamine and serotonin reduce motor neural firing. That means your muscle may still have energy, but the brain's limit output to protect you from um, overexertion. For example, in a lone badminton match, player might notice slower reaction times and weaker smash, even though their muscles still have fuel. That's central fatigue at work, the brain's way of saying take it easy. Okay, this is my 120. Like even my body still have a feel, but my brain told me like slow down. Then I lost the point. Okay, next let's talk about ATP. Uh, the fuel that powers every muscle contraction. During intense exercise, ATP is burned faster than it can be replaced. Without enough ATP, myosin can put off acting, which uh, weakens contraction strength. That's why you feel that burning sensation or muscle failure during heavy sets. Okay, our mitochondria, the powerhouse of the cell, try to keep up by producing more ATP. But as intense rise, hydrogen ions build up, lowering the pH inside muscle cells. That accidentally slow down both force and coordination, making it harder to keep going. Another another major fact is calcium handling. Calcium calcium ions trigger muscle fiber to contract the sacroplasmic reticulum, release calcium when we move, but during prolonged exercise, this release decline. So even if you want to keep pushing, your muscle cannot contract as forcefully because there isn't enough calcium available. Okay, you probably feel this like when you lifting, and if you ever feel a heavy rep while weightlifting, even if your mind is determined, your muscle cells simply cannot contract strongly anymore because both ATP and calcium are depleted. So how can we prevent fatigue? Nutrition plays a key role. Okay, protein helps repair muscle fiber, and carbohydrate speed up ATP recovery, and electrolytes keep nerve signal firing efficiently. With balanced nutrition, athletes can train longer, recover faster, and uh, perform at a higher level. And with consistent training, the body adapts. Exercise increases mitochondria, improves calcium handling, and delays central fatigue. In short, the more you train, the longer you can stay powerful. So what do we learn? Fatigue isn't one simple problem. It's a complex balance between the brain, muscle, chemistry, and nutrition. By understanding what's happening inside our bodies, we can train smarter, perform better, and recover more efficiently. Ultimately, science helps us push limits safely so we can work hard and recover wiser. I want to thank Professor Ake for her guidance and my group members for their collaboration on this project. Together, we explore how understanding fatigue can lead to stronger, healthier performance in any sports.